Alright, welcome to the explanation video of the smallest 5x5 seamless double corner door that I made. It's only 9 times 12 times 4, which is 432 blocks, currently the smallest. And also it holds 6 records in one door because the door itself is limeless, so that basically doubles the amount of records. And being full flush also triples the amount of records, so 2 times 3 is 6. Okay, so before I go into the explanation of the door, I would like to show you some modifications to the door because you can actually utilize the door a bit to make it faster and make the animation better. So I'm just going to do that first. So uh, firstly, for the speed, so each of these changes can make the door be faster by 2 ticks. So there are 2 changes which makes the door faster by 4 ticks, which is 0.4 seconds. So the first change I actually didn't even include here. So previously there is a piston here. Uh, Lagging. Hang on. Okay, so there's a piston here, like this position. So replace that with a hopper because that's not necessary already. And second off is the top. So what you want to do is to remove these 2 observers, so just to prevent them from powering stuff. And then you can basically, don't mind that, that's fine. So you can basically remove these 4 blocks, place a block here, and then place a slab. I should get it from my inventory. Sorry, my laptop is still lagging. Hang on. There you go. Slab. Place it here. This has to be a slab just to prevent this piston from powering. Then you can replace your dust back. And what we're going to change is here. So you place an observer here and an observer here. And then the repeater timings can also be changed. So previously this is the 4 tick repeater, now it's a 2 tick because the extra 2 tick is not necessary anymore. And then you place 2 observers back. Then you can reset the door. If I didn't left out anything, that should be it. Yep, looks like it works. Then the opening. Yep, there you go. So one thing to remind is that you can change either this piston or this piston to a hopper, but do not change both of them because that won't work. I will explain that later. And okay, so this is the speed utilization. Now let's get to the animation part. So you can see that the top parts, the doubles are not powered at the same time. The top doubles, you'll see it here. They are not powered at the same time. I'm using a game speed mod, link in the description. So you can actually fix that. Let me just open it. You can make them in sync, in fact. Yep, there you go. You make them in sync by removing these 2 stuff, and then place a 2 tick repeater, replacing the dust. Place the things you have broken. This 2 tick here will make the doubles in sync. See that? That is in sync. It's also in sync in the retraction. Yep, there you go. So this is the first part. Second part is here. This 1 tick, you can change this to 4 ticks if you would wish. It cannot be 2 ticks, it cannot be 3 ticks, it can only be 1 tick or 4 ticks. And I will explain that part if I remember again. later. So it depends if you would like the retraction to spam a bit, or if you like it to be a one-time retraction for that specific double. Yep, you can see tracks. And then let me just check here. I didn't really change it. Okay, so this is very optimal. Again, just 2 tick. You can change it to 3, you can change it to 4, but do not set it to 1. It can be 2, it can be 3, it can be 4. So depending on whether you like it or not, so you can just change that if you wish. Yeah, I'm not going to change it because 2 tick looks fine to me, but if you want to, you can change that. So enough of the utilization part, let's go on to the explanation. I'm going to explain from like the start of the input to the end of the door, basically. So like how the door powers in that sequence. So let's begin. So this is the first part. This module is to explain how the the folded slider works. Actually, even before that, let's just check out the layouts. So if you can see the layout here, this is kind of weird because you see there's quite a bit of stuff. So these doubles are quite simple, these singles are quite simple, and then of course we need to have the flush pistons, so we push them with sliders, and this time it's quite lucky, you only need 2 of them here and here, so you just have normal sliders. But this is all, these pistons are also connected to the double, so it looks kind of weird. So it has an observer with a sticky piston instead of like just a normal piston. But yeah, that's just how the door works, and that's the easiest way that I find to power the door. Same here for the bottom here, but except the part that you need to have the folded slider. And this door cuts out 1 layer from the previous door by cutting out the bottom layer. And this is how I do it. So normally what you would do in here is to just have something like this, and that adds the bottom layer, to be honest. So what I did instead is to have, let me get a button, thank you, you, hang on, please don't lag, thank you. So you push this here, and then once this does its stuff, and then you push this observer, then this goes up. This is the folded slider, in fact. And then you can pull this down. The opening is the same. Push this, pull back, push this, push up and push down, and pull back. And then only then the top will fire. So yeah, this is the slider part. And one thing you might notice is this piston here. So if you see in the tutorial video, I suggest you watch the tutorial video first before the explanation, but you can also hop on to here, I don't care. The problem with that is that this double, you literally have no way to power this piston, since I added this triple here to avoid another folded double here, because I find having 2 triples is simpler than having another folded double, because once again you need another folded slider, which is not optimal. So to solve this problem, just have a piston with an observer pushing down. But having that would mean that you need to remove this piston first. So you need to remove it to here. So only then can you push this observer down while pushing the piston down. So yeah, that's the drill. So this is basically the entire layout. So let's go back here. So let's just see this powering first. So yeah, you can see this is how the folded slider works. So, and then you can power this, and you can see this observer retracts. And this is also the reason why I need the 2 tick here. So when you see in the opening, both the opening actually, yeah, just the okay. You see this piston already retracts the block. But then this observer is pushed into here, and it needs to go up and then down, and then goes back. And then the part where it goes back, it will also power the repeater, obviously. So you just need a 2-tick, 3-tick, 4-tick. It doesn't really matter. But in any case, you just can't have 1-tick. And this is why you can't have 1-tick. And yeah, the slide just pushes down. I will push it manually because that will be in another part. Okay, so let me explain how this folder slider works first. So the input is here. It literally powers this piston only. So once it powers this piston, then you can see observer here, and then observer going up. So when it goes up, let me just slow it down. And then this dust will power that piston here, which will push this piston, and then that dropper will power through the observer and then power that piston. I don't know if you catch that. So let's do it one more time. So you can see that piston retracts. And because it's a button input, so it will power the dust again, which will pull the flush piston back. So this is the bottom flush part. It is quite simple, but the slider itself is not, because it still requires some more moves. So just going to reset this again. Alright, so this observer also connects to this observer, which will power this piston. One taking this piston, and then one taking the entire slider upwards by 1 block. And because this piston is constantly powered instead of like getting 1 tick, this means that this only gets 1 pulse, which is nice. I only need 1 pulse. If it's a double pulse, it will break. And then 2, pushing this piston constantly means that this piston cannot push because the piston arm is unmovable, which means that it just can't push. But when the observer retracts, this can push the observer after being retracted, and then it will get pushed into here. So let me see if you can catch that. So let me just slow it down first. Don't know which angle is the best. So yeah, you can see this pushes here, and then when the observer retracts, it will power the 2-tick, and then it will get pushed, and then the piston would also push the observer upwards at this moment. So yeah, and since that's a 1-tick, it would basically spit the observer upwards. So what I do after that is to just have this toggle. This is a toggle, a very standard one, observer one. And then to your 4-tick, and then power this dropper hopper. This dropper sends an item here, gets detected by the comparator, and then it will basically push and pull the observer back. But you would see that we still need to pull this observer back to here to revert to its normal position. Position. And that's why you see me flicking this lever here. This single piston actually controls this retraction as well. So that's how I do it. And I will talk about the folded double later, but first, after the lag. Alright. So when the slider gets pushed up, these will push as intended, because you need to push them before actually, like, before this gets pushed out. So this needs to push the block, so yeah. But then in the opening, this slider is already pushed upwards, so this would do absolutely nothing. And only when the top pushes down, which will be delayed, of course, this slider only moves then and gets detected and then powers these two pistons, and that's why they get powered first but retracted last. Basically, this is essentially an ABBA circuit. So that's how I do it. And one last thing, the double. This double particularly. Uh, this observer goes into this observer and then goes into block, powers the bottom one. You might think that's why I cannot just have an observer with this block, and that's because it powers too fast. If I do that instead, let me get myself thing. This here, because this observer, when it goes upwards, and it will also get, you will also detect this dropper essentially. This will get extended and retracted, basically, which is not my want. And that's why I need to delay it just by one tick, just from here. Quite simple. This also derps this piston, but it doesn't really matter, because this is not going to break in any ways. Because for the closing, let me just do the retraction first. The close, let me slow it down. Okay, did I even press that? So you can see this derps. You can see that piston derps as well. This one, but by that time the piston already pushes the observer outwards, so it basically just pushes. Nothing will happen. So yeah, and for the opening is even better. It won't even derp because this piston is constantly extended. And when you see it again, so you can see that piston only gets one pulse instead of two. So yeah, as this piston is constantly extended, it doesn't even derp. And one thing that is quite clever about this layout is that as this sticky piston will retract the observer, this means that I don't have to worry about this piston getting powered, basically. So yeah, that's another good thing. So let me just reset this and reset the slider. There you go. So this is basically the entire folded slider, but this takes like around 2 hours or 3 hours. I don't know, I forgot. But yeah, this is one of the hard parts, but it's still fine. And you would understand the use of this dropper later. And let's go to the for double part first. So it's quite simple, to be honest. Like so first off, this detects the same thing, goes to here, and then this dust would power this piston through this dropper, which will retract the observer. This is basically a toggle because the stone button gives two pulses basically. So only after the slider extends, like pushes the blocks, would the folder double starts its action. So yeah, this powers, and then this here, this gets detected by Vortic through a toggle, so this would push up, and then this would push. You might think that, hey, this dust is literally just a cross. It would power both this piston and this piston. And the answer is yes and no. Uh, this is due to racing condition, as I have used it in quite a lot of my doors, but I can explain that again. So when a piston gets pushed from here to here, and then the piston arriving at this position gets to be extended right after it arrives this position, uh, it will extend the front piston before the back piston. So yeah. As long as this piston arrives and it gets powered instantly, this front piston would extend first, then the back. This is a priority that is implemented in the Western system. So yeah, this is always the role. So, yeah. So once this piston retracts this piston here, this back will fire because it will because this cross will also fire the back piston. So just see it in action. So yeah, this is literally the folded double, and the opening is the same. Yep, there you go, and that's basically it. So let me talk about the rest of the bottom. So I also added this piston and to show you how it would be done. So right after this vortex powers, and you can see this dropper would fire, and then through these two observers. And before you ask, no, it cannot be a dust or like have this a block, and then this should be any powerful conductor. You cannot have that because I remember it's too early, and let's see. I forgot why. uh, yeah. Anyways, so I forgot why I cannot have that. I remember I could add that later. But anyways, so this is going to go down here and go to here, and then this is just another double circuit. If you haven't seen this before, you should probably learn it, because this double allows you to fit the entire double circuit in layout size instead of having the normal vortex into an observer thing. So this dropper is butted. This will actually just do a double. Yeah. And you can see how these two doubles are separate from this double. They are literally separate. So this makes things easier. And then this gets detected via an observer, and then this here would spam, but it will only give this piston one pulse, surprisingly. You can see that here. So yeah, it will only give this one pulse, despite the spam. So it would like do spam 4 times, I think. 4 times, yes. Yeah, but this piston only extends 1 time, like gets powered 1 time, which will extend the block, power this torch, let this torch power the dust, and then power the front pistons, and this is also how I do the toggle. So this gets constant power, and this gets the power. This is how I do it. And finally, to connect to the right side, this sticky piston would extend the slider. This would be useful for later because this is essentially a toggle. It will extend this piston such that the slider piston does not get powered at the wrong times. There you go. So this piston does not get powered at wrong times, so it will extend this piston. This also gets detected by this observer, which will push this piston. The sticky piston here will also get detected by this observer, which will push these two pistons. And this is one of the funkier ones because it gets spammed. It literally powers 5 times. 1, 2, 3, 4, 5. Let me slow it down. If I can. That's just slow. 1, 2, 3, 4, 5. You might think that this is completely unnecessary because I can literally just have this observer to be connected and then go up, but there's a reason. This is actually a very useful way to get to the top, which I will again explain later. So now the sides are basically connected. This layer here looks quite awkward, but is to power this piston, is to give space to power this piston, and you'll see why. So now let's get to the top now. So you can see a bunch of stuff from here already. And yes, this is actually how I even connect to the top. Pulses 5 times, and this would go to an observer and then pulses this, and this would actually get pulsed 6 times. So each piston you add adds one more pulse. So this pulses 6 times, and as this piston pulses 6 times, this observer would detect and give 7 pulses. So basically, each piston you add gives one more pulse. And this hopper is just another conductor, makes it faster, and then goes up. Originally, this is a piston, so it adds another pulse, so it's 8 pulse, but I found out that is unnecessary, so now it's 7 pulse only. So okay, once it goes to here, these dust, this observer gets fired, like this observer will fire one tick after this one. And what this does is actually a pulse extender. If you haven't seen this technique, I use this technique in my Slimeless 555 wire door. This is the first time I used that, but this is like magnified by and a couple of times. So what this does is, since each, like basically the observer would give a pulse every 2 ticks, 2 resistant ticks, this means that this dust will fire. This observer will fire, and then after this observer depowers, this will power, and then after this depowers, this will power, and then after this depowers, this will power, essentially creating a loop. And since this has 7 pulses, this means for a 14-tick pulse, which is basically a button, but less one. A wooden button, but less one. So yeah, I haven't even changed this. I should rechange it. I'm sorry. Please don't lag. Please. Oh, I don't have the slab in me. So let me just fix that. So yeah, this is the modified version. So this gets a 14-tick pulse, really nice. And this would be useful in all of the circuits basically. The top really relies on a button input thing. And yeah. So anyways, let's talk about the this particular double again. This is separated from the rest of the doubles. And talk about the left side again, because as you can see from here, this left side does not even touch the top. It's actually the top that fires these 3 pistons instead of the bottom, because the bottom is quite saturated already. You can't really find another way to part the top via the bottom. Sorry, part the side via the bottom. So I do that from the top instead because it's easier. So anyways, back to here. Let's talk about this flush piston first. This is quite simple. Once this pushes down, and then this piston would get powered by the 14-tick pulse, which would basically get detected, and then redstone lamp gives 2 pulses, as always. This would get pushed down, this would push, and then the observer that would be pushed into here would fire this piston at here, and then and then the second pulse of the redstone lamp, this just retracts this piston. So yeah, that's how you do it. And yeah, and how I do the double, this is another thing. So this observer would go down here. It would go down here and then fire this piston. So when it goes down, it'll fire this piston here already, 1 time. And then this lamp will fire the observer 2 more times. So it will spam a bit. And this is why I need a lamp instead of just another hopper, basically. So this is to cooperate with the double here, because the double, again, it is quite limited in how I can power it, so this is the only way I found. And once this observer retracts, we'll power this one tick. This will also retract the piston because the 14 tick pulse will be over. And then this will power the one tick, and then this lamp will fire this one tick 2 more times. So you can see the opening would spam a bit, but except you can do this on 4 ticks, it won't spam otherwise. 2 ticks and 3 ticks would also spam the piston, but it would not work due to other reasons, which again I'll explain later. So this is basically the concept of this double, and this is quite simple. Go to here, observer here, you can go through this line. This is connected via a toggle, which will power these 2 pistons, and this is also connected to a toggle which will fire these 3 pistons. So yeah, and we can see that in action now. Yep, there you go. And then the opening. Yep, there you go. So you can see how this fires. And then lastly, this would go up by itself, which again will be in another circuit. This is actually connected by the triple circuit. Surprising. So yeah, just for information. And this is basically the entire stuff that I had to explain here. Now let's go on to the next part. So this part is, oh no, I haven't even changed this yet. Let me change that. I mean, it's essentially the same, but I would rather change it. So there would be an observer. Yeah. Then 2 ticks, dust. There you go. Just for the scenario. Even though it's really optional. Is there anything? Nope. Okay. So this circuit is to show you how the rest of the doubles work, and retraction of this piston and pushing down this observer here. And I should also do down 2 take. So once the bottom gets fired, I'll just manually show that right here. This is actually not the layouts, but you know what it does. So when this slider pushes up, it automatically extend already because this observer is here, which would detect the slider. And yeah, I don't even need to worry about this piston. It's quite troublesome to power this piston since there's a lot of circuits around that would just hinder the powering of this single piston here. Quite annoying. And I just end up with having this observer and just have the slider to work with. So that's why you see this piston getting dirt, and there's a reason for that. Yeah, anyways, so once this 14 tick pulse fires and then goes through these repeaters, this is where things gets interesting. Normally when you see small doors, you don't expect to see some features like this, but surprisingly this uses some tilting properties again. It comes in very handy. Okay, so let me explain how this works first. So this observer will power, and then it will fire this dust, goes to here, goes to this hopper, goes to this observer. This is detecting the hopper. This observer will power this piston, which will fire this piston, retracts this piston, and by the time this piston would already push the block down. So yeah, but you're not going to see that here. Okay, anyways, so this piston will get retracted, and only after that would this extend, of course. This will extend, and this observer here, when the observer extends to here, you can power the piston at this level. That's the usuals. And you might also think, hey, this observer is also powering this piston. And this is a one tick. This is a one tick. They basically fire at the exact same time. And the answer is yes, they fire at the exact same time, but due to toxic priorities, repeater has a priority of -1, observer has a priority of 0. The repeater will always fire components faster than the observer. So the priority decides to have this piston fire first instead of firing this piston, which means that it will always push this observer down, then to fire this piston again. So that's how I solve it. And if you would imagine, after the double, this will retract, but then this this repeater will turn off after one tick. This observer will fire after one tick, and right as this piston retracts the observer, this piston would actually extend this piston because the repeater again has a higher priority than this observer, so it would always retract this piston, this observer by the piston, and then it would fire this piston to replace this piston back into its original position. So that's basically how it works. And if my explanation sounds confusing, I'm sorry, but yeah, you can see that in action later. And also, if you are afraid of these two observers affecting the powering of this one, don't worry. This would just basically extend the piston earlier than it should be. But it doesn't really matter because the piston would end up in here anyways, so it doesn't really matter. So without further ado, just power this. And I'm sorry it lagged right at that time. So this piston, yeah, you can see that piston extends by accident. It isn't intentional, but it doesn't matter, really. This piston will retract, and then the doubles will start to fire. And then when it retracts, which will happen soon, 14 tick pulse is quite long. You can see the observer retracts, and the piston gets pushed back into its original position. You might also see that the observer and the piston basically collide together, and that's the magic of toxic priorities, to be honest, because this piston is pushed into the place here while this is retracting still. So yeah, this is quite amazing, to be honest. And actually, in fact, I might have to change this back to the original one because I just realized an issue I can't show you otherwise. So let me just change it back because this is just for me to be easier to explain things to you. So it basically works the same. Doesn't really have any effects if I remember. So let me just test that. Oh, I forgot to. Just don't worry about this piston. I forgot to push the slide upwards. Okay, good. So, to the point of why I couldn't have like a 2 tick or 3 tick here with this double is that the 2 tick and 3 tick would create an immovable block, basically, right? Obsidian. Please don't lag. I'm sorry for the lag again. Quite a few times, to be honest. And wait. So, for a 2-tick or 3-tick, this would basically extend this piston at the wrong time and to create essentially an immovable block here. And you will see what happens to this circuit when there is an immovable block here. See that? This piston is supposed to push, but it doesn't because of this immovable block here. So it has to have a movable block here for this piston to extend because Taoist polarities are quite weird. And yeah, if this here is a 2-tick or 3-tick, this would basically break because this piston is still extending at the wrong time. And yes, you don't want that. So 4-tick surprisingly works because 4-tick only powers once, but 2-ticks and 3-ticks they will both fire twice. 1-tick works because by the time this would push, the piston here already retracts, so there's no worries. It literally works just as fine. So yeah, that's the information. Yeah, you can choose on either 1 or either 4. It doesn't really matter. It's just for the animation purpose. It's due to the funkiness of Celtic parties. Okay, so another thing I have to explain is how the double actually works, because I just said that the double works, but I haven't shown you the exact mechanic yet. I just tell you how this small thing works. So, this double, quite simple. It extends this will fire the dust here, part of this, and then when it retracts, this dust will also fire the piston at this position. So yeah, that's quite simple. But for this one, it's not, because this 1-tick would obviously push, but the piston is already down here, so it doesn't matter. But anyways, this piston would push, and then after 2 ticks, it will fire this piston. But when this piston retracts, this piston will also fire after 2 ticks. Oh, sorry, this observer will also fire after 2 ticks, like after this 1-tick. And that's not desirable because there already isn't enough space. Like, there's a lack of space to power this piston already because of how the triple is placed. The triple is literally right here. Yeah. You literally have no way to power it, basically. So I just have to reuse this observer. And what I actually ended up with is to have this retract, and then delay the retraction of this piston by having a hopper with an observer here. What this essentially does is to add another 1-tick to this piston. So see, when this hopper fires, after 1-tick, it would basically power this piston, but this repeater will also fire 1-tick, so it doesn't really matter. But on the retraction, it matters because this 1-tick would turn off after 1-tick, of course, and this hopper would fire the observer again because it gets turned off. And after 1-tick, the observer will fire the piston again. So this piston basically extends after 1-tick, but retracts after 2 ticks because this observer extends it by another 1-tick. So this observer, so this piston retracts 1-tick later, which then this observer can catch up and power this piston at the final position. If that makes any sense. So yeah, see that. And also this is all just to explain the animation purpose. 1 tick, and then this is 2 ticks on both edges, so 1, 2, 3. So 1 plus 2, 3, and also 1 plus 2. So 2 plus 1, that's 3. So this is how I make it sync. You can make that sync like this. So hang on. So you can see that again. So, and that also fires. So that's basically one of the coolest part of the door, using tile qualities, basically. So at the extension, this would not fire, but the retraction, it will fire. And that's how you control it with such a small amount of space. Really quite clever. Anyways, one final thing. This toggle would fire this here, and also this would toggle the slider as well. And the firing of the slider is also quite funny. It powers through this block, powers this piston, but at the same time it will also fire this piston via the butt. That's because the slider here would slide, of course, and it will update this piston, and this piston would know that it has to fire, so it will also fire. So basically, you don't even need to connect to this piston, you just fire from upwards. And if you're asking how this piston fires, you can already see it. This observer fires this piston literally. So you don't even need to have a toggle. The top fires very late, and this piston will already be at this level when this double fires in the closing. So you don't even need to be worried about it. And in the opening, this will go downwards. And the only thing that you have to be worried is when this piston fires. And for some timings, it cannot work due to how the singles would fire an odd amount of times. Sorry, would fire an even amount of times instead of an odd amount of times, which is no, that's not how I wanted it to work. So the firing of the slider needs to pay just a bit of attention to it, but at the end, it isn't a big problem, to be honest. So yes. Show that again. Oh no, I actually still forgot to fire the slider. And then it's lagging. I'll just do the opening again. So once I remember how to fire this slider again, this would fire, and then this vortex. This also, you can see this piston is already at the top, so it doesn't matter. And then the opening, you can see this would derp a bit, and just for information, one taking a piston and then detecting its body would give 2 pulses, and that's how this works. The top here would extend, giving 1 pulse, and then after that, the bottom piston would extend, giving 2 pulses, and then it will extend again, giving another 2 pulses. So yeah, you can see that. That's why this derps, but yeah, it still works. So don't worry about that. And now I can finally change it back. I still like the new version, that's all. There you go. So after explaining this double and then this swapping thing and this slider, it's finally to the main thing at the top, which is the triple. And the firing of the slider as well. So I also included this thing here, just to push down the slider automatically. I don't have to worry about that anymore. And oh no, I still haven't even changed this one. I forgot to change it still. But it just takes a few seconds. Just mind me, don't mind me. So the triple design is quite trivial. If you have seen some of my doors before, uh, involving a full triple, you can see that on my first video of the 6x6 funnel door I made with Clipler. So you can check that out. It basically uses the same mechanic except it is modified slightly. This is also used in the previous record as well. But how I did it is also modified. So I will explain it right here. I should build this beforehand, but it doesn't really matter. So normally you would see some of my common triples like this, and it works exactly the same way. So you can see here, this would extend, this would power, and if you're wondering how this powers, it's actually quite simple, like how this one ticks. So this will power, and then this obviously will power this one, and then this does will power this piston, and also power this piston via bud, and this will update it, and basically cannot retract it. And when this piston extends, this piston also extends. When this retracts, this also retracts. And since this is a one tick pulse, this would update it such that this receives a one tick pulse. So this one ticks, basically. And when this fires, yes, this piston would, sorry, this observer would fire this piston at this level again. So this would basically retract this piston at this position, and then this observer here will fire uh, this piston here, uh, like so. And you might be wondering, hey, why isn't this piston firing instead? And that's because of, again, racing condition, because this piston just get retracted at this position, and at this position, the piston is instantly getting fired. So the bottom one will extend first instead of the top one. So yeah, again, racing condition, very simple. And finally, this extends and this powers this one, and then this obviously powers this one. So yeah, that's one cycle completed, and the opening is exactly the same. There you go. That's how it should be done. But then, in the actual design, you can see how it's already different. This isn't a vortic. This hopper is essentially the same thing. It's just copied over and then gets diagonally placed by one block. So yeah, that's how it goes. So yes, let me just have this here and then have another input here. So when you see here, this already does the double basically, just using the previous concept I've mentioned. And then the retraction, this observer will fire this the second time, and then this dust will fire it the third time. This is why it derps. And let me just show it like this. Okay. This here fires. This here fires. The top one fire, the middle one fires again, and then the bottom one fires again. And that's why it derps. This is the reason why it derps. And this is also basically how it works, essentially. I can show you the extension again. I haven't showed you that. The middle one fires. The dust fires, gives a one tick. The middle one fires, and then the dust fires. And due to race condition, it will fire the bottom piston only. And then there you go. Just skip it. So yeah, this is basically how this circuit works. Really quite simple and quite clever. It's not the smallest triple design, but I decided to use this because it's more original. But anyways, so this is basically how the triple works. This is exactly the same. Yeah. This observer will power this hopper and then power this piston. This piston is not part of the layout, but it is to push this layout piston and then gets detected by this observer, which will fire this slider. And this is also the reason why I need to push the slider piston away, because if this fires at the wrong state, it will basically push up the slider at unexpected times, and is most importantly, this piston is getting one tick instead of getting constantly powered. This means that this piston will always have a chance to fire, even when the slider is down, and then as a result, it would just end up being this, and you can't resolve it. So that's why you need to avoid this getting power at the wrong times, and you only fire at the correct times. So this is why this is important. And yes, it's quite funny using this piston to basically transmit signal downwards, because you honestly don't have much space at the bottom. You only have a too high space, so you need to make use of the top. And the triple actually has quite a few delay for 8, 9, 10, 11, 12, 12 ticks, and then 13 ticks, so that's quite a lot. So that's already enough for all of these to kick in action, the singles to kick in action. And by the time when the triple gets right, this has a 4 tick again, so yeah, that's quite a lot of delay. So this will fire at the correct times, even though this piston actually derps. So yeah, by the time this retracts, this will fire. So we basically timed that really well. And to be honest, if you just need more delay, you can literally have this here, then have a 4 tick here. Yeah. So either way, I will have enough delay, to be honest. So there's no worries with that. You only need to fire this piston at the correct time. So yeah. And show you in action. Finally. So, and I really just realized that this has absolutely no use. Yeah, you can see this piston pushes and pushes, so the slider fires. Yeah, really quite nice, quite efficient. Uses quite a few blocks only. So that's basically how the triple works. And you can also see why I needed a button pulse, like a button input for the top. The reason is the triple literally relies on a button input. So having this pulse extender is very important, because the triple really needs to just have a long pulse. So spamming this piston is intentional. Spamming all of these pistons are intentional. So really quite nice how I managed to pull that off. And yep, that's basically the entire door completely explained, I think. So, oh, okay. I finally realized why this has to be a dropper. Sorry, why you cannot have like just one observer here from this vortex. I finally remembered, and that's because of this dropper here. So let me explain that at last. So as this double fires, this observer will fire this block, and you might think that hey, that's just firing double, but in fact no, it's not really, because it's also firing this dropper via a bud, and if it gets updated at the wrong time, it will stay budded without realizing it. Hey, I should be off. So essentially, I just need to have this on 2 ticks instead of on 1 tick to avoid this dropper getting budded. Of course, there might be other ways to go around it, but then you also need to realize that this dropper cannot be updated at random times. So having a dust here doesn't really work. Having a torch obviously doesn't work. So yeah, that's why I go for dropper hopper, because this gives no updates to this dropper. And to avoid this getting budded, just have a 2 tick here. It's really quite simple. So yeah, that's how I avoided that issue. And yeah, with that, that's basically the door explained. I hope the explanation makes sense. If you find it quite difficult to understand, you can comment in the comment section below. I hope the explanation sounds a bit more natural this time. I didn't do a script compared to the other times. I would do a script, but this time I didn't. So uh, maybe quite spontaneous, but I hope this sounds more natural than before. So yeah. Anyways, if you like this type of explanation than a scripted one, you can also comment it. I would be appreciated if I see that. And once again, I would like to mention that firstly, this uses OCD Plus resource pack, link in the description below. It's by peterjiangTW. If you're interested in it, you can check out that. And secondly, thanks to GameSpeed mod, you can also check that in the description. This helps me to explain the door quite easily. And third off, if you would like to see the door more in action, I will put the world download link in the description below. You can play with the circuits I built in this world essentially. So you would basically see the screen uh, once you're locked in the world. So you can play with the doors and have a bit of fun and maybe learn something that you would never expect to learn. But yeah, I hope you are interested in this explanation. So thank you for watching, and I will see you later.